Hi, and welcome to question 9 of the 2024 paper 1 for the ordinary level Leaving Cert Maths. So question 9 is starting off with like financial maths, arithmetic, and part 1 says a ticket for a concert in Wales costs £59.50. Using the exchange rate, €1 is equal to 0.85 pence. Find the cost of the ticket in euro. So this conversion factor is useful, but it's not directly useful. I need to know what £1 is equal to in terms of euro. Now, one way in I suppose a conversion factor to always convert something into one is to divide it by itself. 0.85 divided by 0.85 will become £1. Now, that makes sense to do as long as I do it to both sides. So my calculator should be here. So 0.85, 85, 1 divided by 0.85 gives me 1.17. So €1 is equal to 1.176. Actually, I use 3 decimal places. Now, if a concert ticket costs like 59.50 in pounds, how do I convert this 1 into 59.50? Well, I can multiply it by 59.50. If I do that to one side, I have to do the same thing to the far side. Now I'm going to use the calculation here. So that's multiplying that by 59.5. The error won't matter because it's taken in the full decimal place. So €70, okay, is equal to £59.50. And that's my answer. Now, part 2 then says Liam is a member of the venue's loyalty club, so he gets a 20% discount on all tickets. He buys 8 tickets for the concert. Work out the total cost of the 8 tickets in euro. So I can just work out what one ticket. So one ticket is equal to €70. But with a 20% discount, he's only paying 80% of the price. So what's 80% of €70? So multiply by 80%, or the same thing as that is 0.8. So I got 56. So he pays €56 per ticket, but he buys 8 tickets. So that's 56 times 8 gives me an answer of €448. So one Taylor Swift ticket. Let me get 447. I may have used the rounded figure. Yeah, I must have rounded up here and not got the, actually, yeah, I used the rounded figure up here, which gave me a rounded answer. Wouldn't have given me a penalty, I don't think. Although now that I think about it, maybe it would have given me a penalty. And then my figure down here would be accepted as fully correct based on this answer, even if there was a mistake in part 1. But I'm getting the weird answers because of the fact, although this would be what I'd be more expecting from a past Leaving Cert question. Now, part B then says Liam flies to the concert. He finds the following information. He says the airplane emits 28,000 grams of carbon per flight. So 28,000 grams of carbon per kilometer. Now, if I wanted to be smart there, I could say that 22.8 and divided by 1,000 kilograms of carbon per kilometer. That should be enough for an attempt. His total flight distance is 394 kilometers. So you could go 2.8 kilograms by 394 to work out the total amount, whatever. And it says there are 244 passengers on the flight. So question says work out the amount of carbon emitted during the flight per passenger. So that's going to be tricky. Give your answer in kilograms, so we've already done that. Okay, correct to one decimal place. So it's giving out 2.8 kilograms of carbon per kilometer. So we need to know how many kilograms of carbon is it given out over the whole flight. So calculator job, that's 394 multiplied by 2.8. So that's giving me a figure of 1103.2 kilograms. Now that's from everybody, but there's 244 passengers. So if I divide that figure by 2, I should have actually kept the figure. 1103.2, divide that by 244. I'm getting an answer of 4.52 kilograms per carbon per person, per P. Now it says to one decimal place, so the 2 is what matters. 2 is less than 5, so the number before it stays the same. Kilogram carbon per person. That should be it. Let's check the answer. 45.2. What did I do wrong? Okay, I realize why I did wrong, and it's all the way back here. I got 28,000 divided by 1,000, and I got 2.8. I should have got 28. These 3 zeros cancel these 3 zeros. So all my calculations wrong because of that. But let's say the reality of doing that, that's a fairly minor error in the scheme of things. So it might be a full penalty and drop me back from the full marks to the high partial, but it's minor in the scheme of things. So you might get lucky and the marking scheme might be more flexible. But that's the actual answer. So we started off with 1 kilogram is equal to 28,000 grams of carbon. Now I just kept working in grams, so I multiplied by 394 to find out what 394 kilometers is, and I got this massive number 11032000. What's that? Over 11 million. Then I converted to kilograms. So if 1 kilogram equals 1,000 grams, how many kilograms are there in this massive number? I can divide the 1,000 in, and I got 11,032. Divided that by the number of passengers, and I got the 45.2 kilograms per passenger. And that's it. So that's 9 part B. So 9C part 1 says the number of people who will attend a concert, so the attendance, can change depending on the price of a ticket. For a particular concert, this can be modeled by the function A of X is equal to 17,600 take away 160X. Now, this is a linear model. I know that because it has two variables. Now, in essence, this is y, so A of x can be called y, be minus 160x plus 17,600. Now, that can be compared to the linear model, the general form linear model. And we'll see there the m value, the slope is negative 160. The y-intercept is 17,600. So whatever's happening, as x gets bigger, y goes down by 160. So it's dropping pretty dramatically. Okay. Now you could graph it and do all those things, but that mightn't be helpful. Now it says where a of x is the attendance. Again, I always consider that to be y. Okay, and x is the price of a ticket in euro. X ranges between 0 and 110. So, and then x is an element of R, which means it's a real number. So it can be any number. Use this function a of x to answer parts C1 and C2. Now I'll get rid of the fluff here. Okay. Part 1 says, find the attendance at this concert if the price of a ticket is 20 euro. So the attendance is a of x, that's what we're looking for, is equal to 17,600 minus 160 times the price of the ticket is 20. Now it's going to flick onto the answer. Should be pretty straightforward. That's our input to the calculator. That's what I got. So it's 14,400. Okay. Now, the next part then says C part 2. So same blurb on top, but it says find the price of a ticket, okay, for an attendance of 12,800. So in the last question, we didn't know what A of X was, but we were told what X is. So there's two unknowns, okay? In this one, we're being given what A of X is. We're told A of X is equal to 12,800. So because these are the same thing, I can swap them out, okay? And once I do that, I'm left with an equation, but it's an equation of one unknown, which is what I'm looking for. So I'll take over from the notes here. That's where we left off. And then I'm going to try solve for X. So I want to get rid of the 17,600 here. So I take 17,600 away from it. If I do it to one side, I have to do it to both sides. Now that creates an issue in that I have a few calculations to do, but I can do them. 12,800 take away 17,600 is negative 4,800, which might scare you, but that negative will go away. On the right hand side, the 17,600 take away 17,600 cancels, you get 0. And the negative 160x is left there. Now I want x on its own, not negative 160 times x. One simple way to always get rid of something in front of a variable is to divide it by the number. So I'm dividing this by minus 160. If I do it to one side, I have to do it to both sides. So the consequence of that is minus 160 divided by minus 160 gives you 1. Anything divided by itself always turns into 1. Although I don't know why I have an extra minus there. That was a typo. Now on the left-hand side, minus 4,800 divided by minus 160 gave me an answer of 30. So my answer is a ticket price of 30 euro. Okay. So in any equation, there can only be one unknown. So in this particular question, there were two variables. In C part 1, we were given X, solve for the other one. In part C part 2, we were given Y, or A of X, and told to solve for the other variable. So just testing your algebra ability. Now that's question 9, C part 2. Now part 9D part 1 says, for a different concert, the total ticket sales in euro can be modeled by 15,000x minus 150x squared. Now, that's a quadratic model. I know that because there's one variable and there's a power of 2 is the biggest power. So again, x is the price of a ticket in euro. For this concert, the total ticket sales are 3,600. Use this information to show that x squared minus 100x plus 2400 equals 0. So I probably messed things up here, but this is equal to the total sales. We're just not told that. So 15,000x minus 150x squared is equal to 360,000. Now straight away I can drop off a 0 the whole way across and end up with 1500x minus 15x squared is equal to 36,000. Now I could divide by 5. I'm going to go to the answer on the next page. Actually, all I've done here is I've brought everything to one side. I haven't bothered simplifying it. So to get rid of this 360,000, I've taken 360,000 away from it. If I do it to one side, I have to do it to everything on the other side. The consequence of that is that they cancel out. I'm left with 0. On the far side, I have this behemoth of a yoke. Now, to simplify that, I've noticed that like if I divide by 10, I can make it simpler. But if I divide by 150, I can make it simpler faster. I want the x squared to be positive, like in the question here. Okay, so I'm dividing by minus 150 to achieve that. If I do it to one term, I have to do it to every other term. Now, what happens there is I'm left with minus 100, okay, from this first block, plus 1 from the second block, okay, plus 2,400 from the third block, and 0 divided by minus 150 is 0 on the last block. And that's what I'm looking for. So if I order them biggest power down, I put the x squared first, then the minus 100x, okay, and then the number at the end, which is where it already is. And that's it. So that's D part 1. Now D part 2 says solve the equation x squared minus 100x plus 2400 is equal to 0. Now the way to find the two possible ticket prices for this concert. So like we said a minute ago, this is a quadratic, okay? So we could factorize this, okay? Or we could use the quadratic formula, okay, which is, now I'll write it in a second, x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now to know what the a, b, and c are, we compare our quadratic to the general form of any quadratic. And I see there that a is the number in front of the x squared, which in this case is 1. B is the number in front of the x, which is minus 100. And C is the value at the end, which is 2400. Now, if I fill in my formula, I'm going to do any negative number in brackets. Okay, minus 4 times 1 times 2400. I'll run back over this now in a second. So the B value is minus 100. So I replace in brackets the B with minus 100. Now it appears again in the formula, so I do the same thing. Then the A value, which is 1, the C value, which is 2400, and then at the bottom here, the A value again, which is 1. Now I can put this in the calculator. I can put it in and program it just like it is and do it once with the plus, and then backspace and do it once with the negative, which is how the answer here probably is. Actually, I didn't use. I did. Next slide. So that's the formula, the quadratic formula I filled in. Put it to the calculator with the plus, I got 40, and with the minus, I got, I think it was with the minus, I got 60. So I've often given my classes the choice. Do you want to learn different methods of factorization or just focus in on the quadratic formula? And in junior cert higher level, I'd be definitely practicing all. But at Lima cert, as long as you can find the solutions to a quadratic, it doesn't really matter how you do it, although the quadratic formula can be a bit more long-winded. So in the factorization method, I'm looking here at the quadratic, and I'm looking for two things. What two numbers will add to give 2400, but also multiply to give minus 100? Okay. So I try to think of all those numbers. So the ones I thought of in the question, and sometimes you might have to tap away at the calculator, were 40 and 60. So if I'm, sorry, minus 40 and minus 60. If I add minus 40 and minus 60, I'll get minus 100. If I multiply minus 40 by minus 60, I'll get plus 2400. So my two factors are x minus 40 or times x minus 60. Now the value of the factors, I have to put them equal to, each one equal to 0. Okay, and x minus 40 equal to 0, I can get rid of that 40 on the left by adding 40 to it. If I do it to one side, I have to do it to both. They cancel. I'm left with x is equal to 40. Same thing with the x minus 60 equal to 0. If I add 60 to the left, that will get rid of the minus 60. If I do it to one side, I have to do it to the other. And that's how I end up with the x is equal to 60. So personally, I would recommend knowing the minus b formula. And if you're not sure of factorization, just use the minus b. It's quicker to just use it than it is to realize that you can't factorize. And the situation where you might know that factorization won't work is if they ask you to leave your answer to a certain number of decimal places. Okay, you'll only be able to factorize if your solutions are whole numbers. Right, that's question 9, part D, part 2. Okay, and that's the answer. Right, that's the end of question 9. So as always, if you want a copy of the notes I'm working off, send me an email to shanetroy@gmail.com. Like and subscribe to get access to more playlists, and see you on question 10.